It was interesting to me that a couple of people reported that it's still hallucinating and it still really likes to give answers rather than say that it doesn't know the answers. Although it's not so sycophantic about it, but it still really likes to give answers. So it's an interesting combo.
All that and more on today's Mixture of Experts. I'm Tim Hwang, and welcome to Mixture of Experts. Each week, MOE brings together a panel of the finest minds of technology to distill down what's important in the latest news in artificial intelligence. Joining us today are three incredible panelists. We've got Marina Danilevsky, Senior Research Scientist, Gabe Goodhart, Chief Architect, AI Open Innovation. And joining us for the very first time is Merve Unuvar, Director, Agentic Middleware and Applications, Research AI. All right, lots of interesting topics for today's episode. We're going to talk a little bit about, of course, the drop of Gemini 3, some super interesting agent announcements out of IBM, a new eval from OpenAI, and a super interesting report of a cyber attack using Claude. But first, we've got Eiley with the news.
Hi, I'm Eiley McConnon, a tech news writer for IBM Think. Here are this week's AI headlines. Microsoft and chipmaker NVIDIA will partner with AI startup Anthropic in a $15 billion AI infrastructure deal. Carnegie Mellon researchers discovered that AI agents fail a shocking 70 to 90% of the time on corporate real-world tasks. IBM and the Ultimate Fighting Championship have launched an AI-driven live alert platform that delivers real-time records and milestones during UFC events to viewers. OpenAI announced ChatGPT for Teachers, a version of its popular chatbot for K-12 educators. For more, subscribe to the Think newsletter, linked in the show notes. And now let's see what our experts think of Google's Gemini 3.0.
First, I want to start with the big news of the week, which is the launch of Gemini 3. So long rumored, long teased, but finally out. It's a remarkable model. I mean, from some of the benchmarks, Google is reporting explosively good performance on, I think, what has been considered some of the most difficult evals and benchmarks that are out there. So huge leaps on Humanities Last Exam, really big jumps on Arc AGI. But I guess maybe let's just kind of start with like the vibe check. I guess, Marina, have you had a chance to play with the model yet? I'm curious about what you think about it and if it feels like substantively very different from what came before.
I haven't played with it. I've looked at a few digests about it. It does seem like there's a lot of interest in making the more complicated benchmarks be something that's handleable. It was interesting to me that a couple of people reported that it's still hallucinating and it still really likes to give answers rather than say that it doesn't know the answers. Although it's not so sycophantic about it, but it still really likes to give answers.
Right, it's
so
still
it's
making
an interesting,
mistakes.
Combo.
Yeah.
It doesn't like to admit that it doesn't know something, and maybe that's saying something about this new set of models.
Yeah, for sure. And Gabe, quick question. Would you recommend Gemini 3? Have you played around with it yet?
Yeah, I've played just a little bit with it this morning. And I don't know, I think my take on this is we're really starting to see sort of the ecosystem moats evolving. Like, I think this is a necessary step for Google in their AI ecosystem to have a model that is at par or better than all of their competitors, so that they can truly claim to be running ahead in the front of offerings here. But what really struck me about the announcement was that they actually took a swing at a piece of differentiation, because frankly, a really great model is not that differentiated anymore. It's the
like
headline,
not that impressive anymore.
But for what I want to use a model for, what most people want to use a model for, we don't need something better than what we've already got. I thought the thing about the anti-gravity editing platform was really interesting because it actually looked like something novel that they're adding to their ecosystem that you can't get anywhere else. And in particular, the idea of an agentic IDE is not at all new. There are well-known startups out there doing that. There are open source ways to pull that together on your own. The part that I think was novel here was the intentional transition to framing it as a management of agents problem. And tying this all back to would I recommend the model itself, I haven't played with this capability, but a colleague of mine has already. And the idea of being able to launch a fleet of delegate worker agents that can all work on separate tasks in parallel and you can manage them is something that I think has some real compelling chops. So if the model can actually hold up to that level of independence and, parallel analysis, it could be a real breakthrough there on a net new capability that you couldn't get with any other ecosystem. So I'm really excited to try that out and to see where it goes. But from a pure model perspective, I'll play with it.
Yeah, for sure. Yeah, I think that's kind of the really interesting things coming out of all this is like, I think we used to marvel even earlier this year. We're like, oh my God, new model, incredible benchmarks. Like, look at all this progress. But here we are, sitting in November of 2025, and we're like, it's the benchmarks.
I mean,
whatever.
Awesome. The science is amazing, and
Sure.
I can accomplish the same set of tasks that I had before with a much, much smaller model running on my laptop. So.
Marva, do you want to talk a little bit about anti-gravity? I did think that this was sort of like the big, interesting differentiator on the announcement was to say, hey, we acquired Windsurf. We're going to do kind of our IDE, and it's going to be an agentic IDE. What's your take? I mean, where is this all going? And I guess if you want to give our listeners an intuition of like why Google is even investing in that kind of differentiation.
I think Gabe alluded a little bit to it, right? The ecosystem play. But I think this, I haven't played with anti-gravity. I played with the model and I'll share my experience. But this, I think they're aiming for the advanced tool use. So the whole agentic applications and the making tool calls more robust, and also increase the modalities, right? Like they're claiming you can do editor, terminal, a web browser, and like many different, execution modes. And this means you can plan, code, execute, verify different tasks more autonomously. And I think agents in anti-gravity will also generate artifacts. That's what they claim. So this can task lists, plans, screenshots, I think browser recordings, and they can also document, I think, what they're doing and why they're doing with their reasoning capabilities. I think these are important elements when you want to take agents to next stage beyond benchmarks, from academic benchmarks, to put it out there to reality. So it's quite promising. But I did play with the model. I didn't play with the anti-gravity platform yet. So as Marina said, it's not hallucinating fully, but just like other big models, it's really, really good at, with the initial prompt, like the way you describe your first set of things. And they have a build section, right? Like you can build artifacts, like you can build UI elements. So I asked Gemini to create me a workout plan and an interactive dashboard to track my workout sessions. And I told my weight, height, age to customize for myself. And the very first UI that was really nice, and literally like I was multitasking in a meeting, and it like locally I was able to build in Streamlit in less than 2 minutes. Then I asked it to add some more, personalized pictures, like motivation pictures, customized with my name. And then I realized it added a reminder section saying that I should eat high nutrition food after the workout to grow.
To grow,
and I'm
okay.
like, I'm a mother with 2 children. If this was for my kids, I think it would make more sense. But for me, I'm not growing. It totally messed that part up. It already knew my age, so it was I'm way past growing age. So again, the overall performance, I think on benchmarks are quite impressive, and the claims they're making. But and I think this excited me because I think this is the largest capability jump we've seen in a few months, right? Like it's nice, but it has some flaws, which I personally experienced in my first UI dashboard that I built with it.
When Marina, hopefully you can help me kind of square this circle here, because I think it's really interesting that your first reaction to this model is it's still hallucinating. And we kind of have this like very funny sort of split screen experience of these models where they are just kind of performing better and better against these benchmarks. But yet our kind of everyday experience of these models still is that they are making, they're making these hallucinations, they're making these mistakes. Like, what do we take from that? Is it true that the more powerful models just simply hallucinate more? Or is this kind of just like, I'm just kind of curious about like, they're seemingly really strong in some things, but remain kind of like amazingly weak in other domains?
Right. So I'm going to agree with what Gabe said, which is the whole point of, well, plenty of tasks. I don't need this really large model, and I can do a better thing with a smaller model, because hopefully we're trying to, finally getting beyond this idea that we're going to have one model to rule them all. This never should have been a goal. It's never going to work for an LLM with the architecture that we have. What you want is a suite. Either you give them different instructions or different preferences or whatever. If you wanted to do better on these very complicated benchmarks, which really want the model to think through a lot of things, generate a lot of thoughts and attempts and whatever, then you don't want it to be reticent and sit there saying, I don't know anything. I'm going to twiddle my thumbs because I don't have a citation to offer you. These are different tasks. This is the same thing as if you were to, have the statistical tension between precision and recall. You're going to do better in one, you're going to do worse in the other. It's just going to be a consistent thing. Use them for different things. And, the fact that the more interesting thing now is automation, the more interesting thing now is really the multimodality. Yeah, lean into that because that really is more interesting. Having one model is always going to do the best job at giving you the right information. Why? Review your Karl Marx, review your division of labor. Like, let's reinvent normal civilization of people working together. It's going to be more effective. It always will be.
Yeah. And I think it's kind of funny where like this is all resolving to because, I agree. One of the things that was like, oh man, this is going to change everything was, one model to rule them all. But if we like end up in a world where, I don't know, we have very specialized agents for very specialized kinds of tasks, like, are we back to Appland again? Are we back to like software again? It's like in some ways we're kind of like reconstructing applications, like specialized software again, which I guess is like, everything old is new again in some sense.
I think it's a healthy tension. I mean, I think, frankly, one of the reasons we're in the AI moment we are is that the pendulum really swung with the introduction of transformers, and suddenly you didn't need a complicated suite of software to get 80% of the solution. And that was a real game changer, right? I think what we're seeing here is the general purpose populace is still going to use one chat window, right? They're going to jump to a chat window and they're going to enter some things. Now, if that chat window becomes an increasingly complicated software machine behind the hood, the user doesn't need to know. So the interface change of one model to rule them all, I think is sticky. I don't think that's going anywhere. But the actual implementation behind the scenes, I think, we've already seen that with the GPT-5 series. I think we will almost certainly see it with other frontier model offerings, let's call them that. And I think we'll see the open equivalent of a software stack emerging that allows you to ensemble models for specific parts of your workflow and specific elements of how you want this all to work together, exposing that nice single entry point that users want to interact with. So I think it's a healthy tension. The nice thing here, as a software architect, you get an abstract interface, which is your chat box, and then you get to implement it however you want. So we'll iterate on that implementation because we're software folks and we like to do that.
Yeah.
But I think we'll swing back and forth a little bit on the complexity behind the scenes.
Yeah, for sure. I think it'll be so funny if we end up in a few years, people being like, well, rather than a chat window, what if we had like a desktop with like icons you can click on? And it's just like, we'll be back to where we were. So,
Yep.
Two very interesting announcements out of IBM recently about agents. And Marve, one of the reasons we wanted to have you on the show was this is sort of your life for really the last few months. And I think particularly on Gabe's last comment, I understand one of the announcements is around a project called Kuga, Cuga, which is billed as an enterprise-ready generalist agent. So do you want to talk a little bit about kind of like what the team was working on and thinking about for this launch?
Sure, happy to. As you said, this has been my life since the launch, and it's been I think we got good feedback as well. We're trying to become enterprise-ready generalist agent. It's not an easy task to take on. But where we started is like everybody else who starts to build enterprise-ready agents, you start from some simple, traditional way is build a domain-specific agent, some maybe React, Kodak, the simple, pattern that you take. And then you start evolving it to, my task is too complex and my single agent cannot, handle this. So let me go and build a task decomposer on top. This is now becoming this agent architecture where you have the, the layer up top that picks the right sub-agent to do. It's classical engineering design principles because it's easier to distribute to the sub-agents. We believe it's going to work faster. And then what we realized is we're not the only one that does this. Like my peer groups in IBM Research, when they build sophisticated agents, they go through this experience as well. Let's start simple, and then it all of a sudden becomes this very complex.
Like, oh, man.
Exactly. And then we stepped back and we thought maybe we can create a generalized version of this where people can jumpstart with using Kuga architecture rather than building all these things by themselves, right? Like, so we can give Kuga, which is this multi-agent supervisory layer already embedded in the multi-agent architecture, and people can configure it for their own domain and uses. So rather than is a traditional way, like build domain-specific agent, evolve it, do some custom benchmarks, and then long development cycles, at least like a couple months, to new way with Kuga, just take it, validate it, and then bring your own domain, onboard your own tools, and configure for your own domain to do your own benchmarks and then deploy. So that's our vision. It's open. It's outside in the open now for people to try and give us feedback and see if it works for their domain. So we're very excited that we launched in the open so we can capture if what we experimented in research is actually can be mimicked in the real world application uses.
Yeah, that's really exciting. And I think one of the things that we've been watching really closely here at MOE is what I love about the kind of agent competition world is right now we're very much in the world of like norm setting, right? Like we're doing it this way. We hope you do it this way as well. And like I think like there's various projects that are kind of like more or less kind of successful at attempting to kind of build those standards. I think what's really intriguing, and Gabe, I'm curious if you want to talk about this in the context of Kuga, is it seems here, like what's really intriguing, Marve, if I'm hearing you right, is that like everybody starts by building an agent and they all discover like exactly the same problems over and over again. And like everybody's going through that process of rediscovery right now. I guess, Gabe, that's like pretty promising from the point of view of like, okay, let me just shortcut this. Here's a standard framework.
Yeah, I've been also thinking a lot about this, having a lot of conversations with different teams building different components. And one of the things that really seems to be true is that there are emerging slots for a abstract architecture for agents in open source and presumably in closed source, but we don't know how those tools are implemented necessarily. The generalist agent is absolutely one of those slots, and having an open offering that's configurable and permissively licensed is a really awesome place for people to start collaborating and building on top of this. Tool management is another big piece of this. And it just seems to be coming up over and over again that this sort of emergent architecture is there. And to the point about, refining and iterating on the actual agentic architecture itself, the analogy that I keep coming to when I talk about this stuff is if I asked anybody out there working at really any company, please go build me a REST API server for X, Y, and Z. I wouldn't have to tell them the architecture of that thing. I wouldn't have to tell them what programming language to use. I wouldn't have to tell them, like, it's just kind of a well-established pattern that everybody knows how to do if they've ever touched cloud software. Agents aren't there yet, but as many people have said, 2025, the year of the agent, I think by the end of 2025, we're going to be close to actually hitting that point where we can just say, hey, build an agent for this, and everybody just knows what you mean. And as you exactly described it, Merve, I think the decomposition is exactly that step from I got it running in Flask on my local machine with HTTP to now I've got a server that has, middleware for authentication and serves TLS and, can actually be horizontally replicated, right? Like those are the steps you take when you're building a microservice after you get your demo app running. The same thing you're describing with Kuga is exactly what people are hitting with after they get their first React agent off the ground.
You mentioned here's the agent, go use it. Like we're really trying not to, put people to like, okay, this is Kuga, is this, and like you have to use it. Like it's also flexible. The configuration piece makes it, I think, easier for people to, okay, like I need this, but I can configure it this way. And also what we did is, which is, I think maybe it's a good time to introduce the ALTK, which is the Agent Lifecycle Development Toolkit that we also released in the open. We componentize Kuga, and we build different components to support Kuga's different capabilities like memory, guardrails, and other things that makes Kuga function in the real world. But some people may not want to start from Kuga. They may still have their own sophisticated, agent that they built, and they don't want to, move it to Kuga. So they can reuse these components under this agent lifecycle toolkit. And if they want the memory piece, and they can take it and apply to their agent. And this is again like democratizing and not really pushing people to use. This is what I have. This is it works, and use it. No, like there's flexible design. You can take the different components and apply to your current agentic implementation if you want to improve certain aspects of your agent.
Marina, I want to go back to kind of the comment that you made a little bit earlier when we were talking about Gemini 3 and kind of this movement to sort of like more specialized agents over time. It kind of strikes me that like we will almost like reproduce like human org structures in agents because this generalist agent is kind of like it's the middle manager, right? Like its role is to manage other agents. Do you think that's kind of where we're headed ultimately? Is like we're moving away from one agent to rule them all, but there will still be these kind of generalist agents, and really their role will be sort of that middle manager, I guess, in the org chart of agents.
I think there's a reason why when you have any kind of an organization from human societies to biology to software, you have this combination of hubs and spokes. There's a real reason that you end up settling in maybe it's going to be a different number of spokes, more hubs, fewer hubs, but sort of like as you figure out the way to solve a particular problem, that's still the place that you solve. You need some specialists and you need somebody doing the managing and the planning. Yeah, what's interesting about this era is that we are able to go faster, further than we thought. But if you take that 10,000-foot view, it's still all right, I've got a task. I maybe can do, I think, the spokes parts a lot faster, but you still somewhere in there need a hub where you say, okay, this is what you do next. This is how you know that you're done. This is what you try. It's very natural and very correct. The technology to get us to go faster is great. And it's very exciting. But yeah, this is the normal pattern of problem solving.
Yeah, like the future is kind of like figuring out how you staff your project with different kinds of agents. It almost feels like so.
And maybe a couple of people in there just to keep an eye on
There's some actual
things
humans in there
on
as well. Yeah,
occasion.
exactly. Yeah. So I guess maybe a last point, Marve, where are you headed next with all this? I know you had said this is your life since the launch, but where does Kuga, where does ALTK go next?
So just like Gemini 3 benchmark results, so we started with Kuga and then we went out there and found the most challenging and most representative benchmark that we can go after, which was Web Arena and App World. So we were number one on both of them for a long time. And we kept like, oh, let's keep our position as number one. But no, I think like it's very different to keep our position in benchmarks as number one versus putting it out there and hearing directly from the users where it breaks, how latency is, for example, a problem right now. Apparently, like when we built Kuga, we really focused on the accuracy and how good Kuga behaves, like listening to task. But latency is one of the requirements, for example, for us that came from the real users when we launched outside that said like, okay, this is too slow for me to use. So we have a bunch of things that we captured from the community that we would like to incorporate. But also when I mentioned like the ALTK, which is the core components that helps, I think, agents or agent builders boost their agent performance. There are a couple of things that we're working actively on. One of them is the memory that I mentioned. And I'm not talking about like storage and data structures. I'm talking about what can you make out of this memory, like what you want to remember, what you want to forget, and what is the middle ground that you want to keep learning from, because like some tool combinations may never work and then you already did it and your trajectories, you have this, right? Like it's saved in memory. And can you bring it up and do some self-learning for Kuga or other agents? And the other one is the consistency. Like this is extremely important. And there is not a single definition of consistency in the literature. When you look, people define maybe sometimes with repeatability. But in the, I think, enterprise setting, especially also in the consumer setup is important. Like you don't want your agent to do something in a way one day and a very different way in another day. So how can you bring this consistency to the real world agents? Therefore, they are within their own, world, consistent with their behavior, and they don't throw, really ridiculous answers one day when you ask the same question. So these are the two main topics that we're working. I know.
Yeah.
And we're excited that we're making progress towards like getting the real feedback from the community and also advancing the capabilities of Kuga with these components.
That's great. Well, we'll have to track the project. How do people find out more about it if they want to keep up with your work?
Sure. There's kuga.dev. This is the Kuga's website where you can go to GitHub and learn all the blog posts and other things. And we have altk.ai. So that's the individual components that constitutes and helps Kuga perform better. So if they go to these two websites, they're all good.
Nice. Yeah. Those are the solid TLDs right there. So. Well, I'm going to move us on to our next topic. This is kind of a recurring theme for us in 2025. And I think it's kind of a sort of interesting ongoing set of discussions about how AI will impact the economy. And I think overall, I would say the discussion has matured, I think, over the course of, the last 12 months. I think in the beginning of the year, we were still very much like all the jobs are going to disappear because of AI. And I think now we're getting more to the mode of like, well, like, let's do an eval on that. We're approaching it in a very like machine learning way. So OpenAI announced a benchmark that they call GDPval. And essentially what they're trying to do is to say, well, we have all sorts of benchmarks on trying to evaluate AI capabilities. But one count against a lot of these benchmarks is that they don't tend to be very realistic, right? Like, not frequently, take frontier math, for example, not typically are people sitting down and saying, I need to do graduate school math and like solve like complex math theory problems. So what they do is they basically curate a set of tasks from a number of actual professions, and they evaluate whether or not AI is able to kind of produce outputs on par with a human expert. And they run this as a way of kind of trying to get an assessment of, well, what are the effects of AI going to be on the economy, particularly against these sort of economically valuable tasks. And there's some interesting results. I think the big headline is that, even though it's a benchmark for OpenAI, they discovered that Claude Opus 4.1 is the strongest performer against these tasks. And in some cases are able to reach sort of near parity with human experts. And so I guess maybe, Gabe, maybe I'll turn it to you. I'm curious what you read from these types of results. Are we still kind of back where we are like December 2024, which is like, oh God, AI is going to replace all the jobs? These are certainly really impressive results, but how do you parse through it?
Yeah, I mean, I think in professional settings, the promise of AI has been take away the stuff I don't want to do so I can spend more time on the stuff I do want to do. I think it's really easy to poke holes at benchmarks because measuring things is really difficult. So I want to upfront say, like, this is a really good stab at a new aspect of benchmarking. And I think especially the reliance on human experts is important in this space. The holes that I saw immediately looking at this were they're still doing this as basically one-shot artifact creation as the benchmark, which I don't know about you guys, but most of the time I spend at my job doing things I don't want to do is stuff that involves like investigation, asynchronous, this, that, and the other thing. And in fact, when it comes time to create artifacts, that's the stuff I do want to do, right? Writing code is my happy place, even if I'm using an assistant for it. But what is less happy is wonking around trying to find the, correct way to implement a little corner edge on the internet, or we're still trying to look through a giant pile of corporate docs to figure out the right official approved tool to do a certain piece of my job. So I think the measure, every benchmark makes approximations of the space so that it can actually translate from a fuzzy human space into math. That's just the nature of benchmarking. And in this case, they've made some approximations that, while valuable, still have some holes in it. I think the other part of it that I saw that was interesting was that they actually used human graders, at least as the gold standard for evaluating, because even if you put aside the fact that these are sort of canned problems, very well curated canned problems, but still canned problems, it's very hard to say, is the answer here right? Because at the end of the day, you need a thumbs up or a thumbs down, or at best a value between 0.0 and 1.0 to say how well did this thing do. And that's much harder the more complex the thing that it's trying to do is. So using a human grader is, in one sense, the right approach, but the whole reason we're in this Gen AI boom is that we figured out ways to not have humans labeling data. And this sounds like we're back to humans evaluating data. So they also created like a proxy to this with another model that could proxy what their human graders did. But now you've got AI evaluating AI, and you're kind of in a recursive loop there. So I think it's really interesting to see this try to tackle real world problems. The other piece that they didn't really articulate very well was amongst the classes of problems that a given profession has to tackle, is this tackling the hardest ones or the simplest ones, right? Responding to email or responding to Slack is not the most mentally challenging thing I do, but it's a lot of what I do all day. And, I'm sure the same is true for a lawyer or a doctor or a nurse or anyone in a professional capacity spends a lot of their time in the long tail of less mentally taxing work. So I'd be curious if there's any way that they sort of evaluate these tasks against, is this the low lift or is this the high lift that they're trying to evaluate against?
Marina, you're smiling through Gabe's explication of GDPval. Curious about your take. What I'm hearing from Gabe is better, but maybe not good enough, right? I can think assessing what is ultimately like a very complex thing, like what is a job, So
Yeah, so I really found it interesting diving into this. First of all, props to whoever in their comms or marketing or whatever team thought several months ahead of what the write-up headlines were going to be, because the headlines of AI can now do half of, our jobs, great. It's not what you're supposed to get from this, but fantastic. How they chose the jobs, the fact that they actually went to, the BLS types of jobs and how they went about it. Very, very nice choice. So I like what they're trying to do, very much so. If you actually go and read through the data points, which they made available on Hugging Face, very good with the transparency, it's mostly planning tasks, summarization tasks, the kind of things that actually LMs are pretty good at. And reading between the lines, it did seem to me that they had a lot of different submissions and they sort of narrowed them down until they had a set of maybe similar kind of looking tasks, even though it was across a number of jobs. And we're still only talking about a couple hundred tasks that really got made. So I think that is first of all a point, that it's only going to be so many. And I completely agree with Gabe. There's going to be some tasks that are harder, some tasks that are easier. When you look at the prompts themselves, as I read them, they looked to me very detailed, very refined, somebody with a very clear idea of what they want. So I think a lot of sort of pre-work already goes into before you ask, hey, write me the summary, write me the schedule. I have prepared some files for you. I have prepared some reference Excel, some, sites that I need you to go to. So there's a lot of sort of pre-planning. And then this does the, all right, fine, put it all together. Probably this still helps a good amount. And it also, if anything, would give an example to people who don't understand what does it mean, what kind of jobs can the AI be kind of decent at, which is, look at these kind. Please read these 200 and take a look at what is the kind of thing that this is actually pretty good at. So I like that part of it. Now, as far as the valuation goes, look, it's pairwise comparisons. Is it the most sophisticated, detailed thing you could dive into? No. If I had to guess, having, done evaluations for years and years, is they probably tried a variety of other things and got a lot of noise, because the artifact that you get out of each of these is going to be very detailed and very noisy and very difficult even for a human to say this part is really better, this part is really not that much better. No, it's going to be like this, like this, like this. So they finally just ended up going with a win rate. So I wouldn't really listen to the headlines. I would look in interest at the paper, especially the appendices, where they really go into the process of how they did the evaluations and what does it mean with the automatic grader, not the automatic grader. I'll add one more thing. These are all prompts. So there's not a lot of breaking it down, exactly what Gabe said, exactly what we were just talking about with Merve of first do this, then do this, here's an agentic plan, here's this kind of thing we can do. This is a prompt, and it primarily would like the model to present something akin to maybe a plan that perhaps you would then execute on downstream. So again, this is a very particular type of task. It may be interesting in the future to say, actually, let's have multiple models thrown at this with multiple, capabilities, maybe even specific models, et cetera. Now, is that evaluation of that going to be harder? Exponentially, which is probably why their pass at this benchmark was the way that it was. It was very intelligently done, very ready for headlines, ready for write-ups, ready for all of that. But I do like the interest in real-world tasks and the lens that this can hopefully show on when we talk about AI taking our jobs, which jobs. I wish there were more write-ups that dove into the actual data. I find that more interesting than the final evaluation.
Yeah, absolutely. That was a great analysis. Marve, maybe a final question for you. It strikes me that there's a really interesting tension in what Marina said, right? Which is you want the eval to measure real-world tasks, but it turns out the real world is really, really messy. And so methodologically, it's just very hard to do a good eval here. there's kind of a part of me that's like, we're going to spend a lot of time in the next few years trying to develop increasingly sophisticated evaluations to measure the economic impact of AI. But also, like, the economic impact of AI is just going to kind of happen to us as well. And I'm kind of curious about, like, if you, like, what you think about the value of this kind of exercise. Like, there's almost a point of view, which is we can spend a lot of time trying to create, like, better and better proxies, but we're also just, like, in the middle of it right now. And I guess the effect of AI on the economy, we're just about to see. And so I guess the kind of question is, like, do you think these evals are more important with time, less important with time? Like, as kind of a research area, where should we be going with this kind of work?
Well, I think just when we were discussing this, it made me remember, like, I had a client conversation, not a client, is a friend of mine last week in Istanbul. He is one of, like, CEOs of one of the most leading hospitals in Istanbul. And he told me that, like, it makes him very uncomfortable to see that each doctor has a medical secretary attending patient visits. This is one of those 44 occupations they include in the GDPval. Like, this is exactly the description of the, like they are ready, like, the people who wants to adopt LLMs, like, because there are certain tasks, like, this is a perfect use of LLM, right? Like, we'll listen to conversation and it will summarize, right? Like, a summarization is a very popular use case. And also, like, if you just take this task, fine, we can benchmark and evaluate, but there's implication on other things, like there are other added benefits. Likely a bench would vary, like, almost impossible to measure, right? Like, if you consider these other aspects of these, this particular example that I give, that you can drive insights, right? Like, from doctor-patient conversation, you can extract, for example, the best practices, right? Like, one doctor may be doing something that is working more for specific certain diseases for subset of patients. You can do better process optimizations, like supply planning for a surgery, if you know what's happening, like, in a conversation, or customized follow-up contents, like many different other added benefits you can drive. But each of them, like, it's so difficult to measure, to Marina's point. Like, even non-human evaluations are not that easy. Now we're adding this human component and derivatives of these, like, one per, like, occupation that I gave as an example. But it's real. Like, I had this conversation last week with a person who is looking to implement this in their hospital. So now it comes to, like, where the real world is heading versus, like, what do we benchmark? How do we benchmark? When you implement these systems in the real, you can also track the added benefits as a ROI, right? Like, how much better you are in your supply management, right? Like, for your surgeries and so forth. So you can have KPIs that can help you understand, I guess, the added benefit. But on the paper, just, like, pure scientifically, like, looking and trying to mimic and understand what the combination of things that these tasks can lead, and then try to benchmark against all of them with some data, whether it's human annotated or AI annotated, to me, is going to be extremely difficult and overwhelming exercise. But I do like this because it's helping us from getting out of our academic mindsets when we compare the models and usages to really, like, real world examples, and where, industries are starting to adapt and change.
Yeah, I love that. It's kind of like almost like the eval is sort of also just a useful exercise in terms of being like, how do we decompose this task anyways? Like, what do we do with our days? It's like actually a really
Exactly, right?
important part of it. Great. I'm going to move us on to our last topic of the day, which I think is actually, like, now that I think of it, weirdly related to what we were just talking about. So the final news is this really interesting story that was actually tackled in more depth in the Security Intelligence podcast. Chris Hay, a frequent MOE panelist, was on there debriefing it. I'll give the summary of the story, and then I'd actually love to link it to specifically what we were just talking about. Anthropic disclosed basically that they discovered that an actor, which they believe to be a state actor, was misusing Claude to launch a sophisticated cyber attack. And they have this long blog post, which is kind of very interesting, breaking down what they discovered about the attack. But I think the thing that really kind of stood out to me was this quote, which I'll just read, which is, quote, "The threat actor was able to use AI to perform 80 to 90% of the campaign, with human intervention required only sporadically, perhaps 4 to 6 critical decision points per hacking campaign." And as far as I know, this is kind of the first real dead to rights example of what people have been kind of theorizing as, like, vibe hacking, right? Sort of the idea that all of this agentic technology at some point gets used for good stuff. It also gets used for bad stuff. And I guess to link it to what we were talking about earlier, Marve, maybe I'll kick it back to you kind of as our kind of agent expert here. it does feel like if we had not like GDPval, but for evil tasks, it really does seem like AI is making a real impact in cybersecurity, cyber attack operations right now. I guess the question to be asked is like, do you think agents are going to favor illegitimate cases faster than legitimate ones?
Well, so even though I work on agentic systems, I'm not a security expert, but I did chat about this. One of my coworkers, Ian Molloy, who is leading our agentic security work, and his own words were like, it will be extremely difficult, maybe impossible, to prevent malicious use of these agents while preserving their legitimate use, because like it's designed that way, right? Like we want them to be flexible, we want them to listen, instructions, we want them to do what we tell them to do. On the other hand, when we tell the malicious things, like with these current alignment approaches, I think it's going to be impossible. But what we can do, I think like security researchers have been predicting this from the beginning of the LLM era and not even before agents, right? Like, because you can also do this model attacks without the agents. But what I love is the Anthropic had, I think, the perfect, telemetry and monitoring to be able to talk about this and show what happened. And I think we can instrument our systems with this observability layers or some monitoring capabilities that is going to be basically showing us transparently what is happening in the system. And you can maybe, rework back or talk about it and then learn about what happened. I think that's like, to me, like, we can't control these things. We can build additional components like for security, like authentication, other things, and maybe for enterprise settings that might be even, to me, easier than broad use, right? Like, because you can add some controls when you implement agents in the enterprise setting, but in the broad use, like, you just, do what the user says. But I think like if we instrument the systems with these components, and which one of them could be the, as I mentioned, observability and the robust telemetry and monitoring systems, that's what I think can bring trust to users while they're using these very powerful or small models, whatever they do, to feel comfortable and trustworthy for these systems.
Gabe, I was joking with a friend, which is that there's probably like a team at OpenAI, which is like kind of relieved that they weren't involved in this attack, but also kind of jealous that they chose Claude versus OpenAI. I guess I have a kind of interesting question here, which is like, why not use open source here? It feels like incredibly risky for like an actor of this kind to go with like a model that's provided through the cloud, is monitored like the way that Claude is monitored. It's sort of very interesting. Do you have a hypothesis on why that's the case versus saying we're going to run our own on-premise solution, if you will, to run this attack?
My answer is that they probably are. This is just the ones that got caught, And I think to your point about OpenAI feeling bummed that they weren't part of it, maybe they just don't have the telemetry to notice. Like, I think we've seen one example of this and had it exposed to the sunlight, but that does not mean that this is the only one out there. In fact, I strongly suspect, and they mentioned in the article, that it is not the only one out there. So I do think, there is generally the frontier models are generally closed. Even now that we have extremely capable open models like the recent Kimi K2 Thinking and Minimax models, they're extremely hard to run at scale. So depending on the division of labor, if you've got a team that's the experts in the cyber hacking side of things, they probably aren't the experts in running the expensive GPU rigs to run these extremely large models. And I think what you get with running all of this through a frontier model is the hands-off nature of it versus trying to put this together more piecemeal. The interesting thing, too, is in the cybersecurity domain, the attackers always have the advantage unless they are targeting one very specific needle in the haystack, right? If their goal is just to go get what they can, steal what's available, there's no penalty for screwing up, right? You just keep trying, right? So this same set of actors may very well also be banging on an open source version and one using GPT star and one, just try them all. Why not, right? Like, what's the downside other than it costing money? But the defenders have the much more difficult task of catching everything that slips through, right? Like, you have to have ironclad practices to avoid being, in the spotlight of these things. So screwing up has huge penalties. The thing that did strike me as interesting in all of this, just to look at that defender view of all of it, is that eventually, even though the agent was taking a lot of the decision making and the sort of scripting and the basics of how do we craft this attack, it still all exploited standard vulnerabilities, right? Like it seemed to me like most of what they were doing was looking for systems that were running exposed and vulnerable versions of known exploits and then exploiting them. So if anything, this just puts a finer point on enterprises needing to stay up to date with their CVE patch fixes and just all the best security practices that we've all had hammered into us, just really do them. No, for real, do them. Like someone's going to find it, really do them. So I think, the defensive side of this, there's sort of the AI element of the defense, which is like, how in the world do we catch these things? What do we put into our AI systems as we're building them to make sure that they can't be exploited? And then there's just the good old fashioned cybersecurity of like, patch your software, people, like do it for real, or you're going to get hacked. So I think it's an all of the above strategy on the defense side. But if anything, this just makes it more urgent that patch fix timeline.
I love that we're kind of landing on like, if there's an evil version of GDPval, say like evil Val, we're kind of landing in the same place, which is just like, at the end of the day, these are not very complex tasks, that are being implemented. Marina, I'll give you the last word if you have any hot takes before we close the episode today.
Nah, I agree with Gabe that, again, I'm not a cybersecurity expert, but it seemed like here it was not creativity, but yes, scale, where it was just try the same well-known things, but just try them a lot faster than a human could do them. Okay, so probably at least a lot of those things could be done. One thing I kind of liked was the Anthropic team slipped in there that they actually used Claude to analyze the logs of what was going on. So something that then comes to mind is, well, should we maybe be thinking that the models themselves know what they would use if they were turned to evil, so they're more likely to catch themselves than what a human might come up with? So, and then the different models have different biases. So maybe they could be, like to have OpenAI models, check the Anthropic models and, try to see what you would come up with. Yeah, so this is going to continue to be a little cat and mouse game here, but at the end of the day, it's almost like the tasks. Like I agree with Gabe, like just do the basics, because now you can just have your basics broken a lot faster. So you really need to do the basics,
get the basics right,
please. Yeah.
Well, with that bit of very good advice, we'll close the episode today. Marina, Gabe, Merve, thank you for joining us for the show today. That's all the time we have. And thanks for joining all you listeners. If you enjoyed what you heard, you can get us on Apple Podcasts, Spotify, and podcast platforms everywhere. And we'll see you all next week on Mixture of Experts.